Thank you, Celine. Thank you for having me. Let me first start with a message from Daniel, our CEO and co-founder, and the Lilium team.
We promised the world a 5-seater jet. Today, we are delivering on that promise. It takes off and lands vertically. It's fully electric. This is the Lilium Jet.
This is the product. There's nothing like this.
Yes,
Lilium Jet is clear to take off and going for
Taking off in 3, 2, 1.
What an exciting time to be alive. What an exciting time to be part of such a journey. Imagine when it takes off for the first time, 2,000 horsepower. It started, though, 20 months ago on a blank sheet of paper. So obviously you've seen the 2-seater version flying in there, and then we went from scratch and re-engineered the aircraft at aerospace grade. And from that 30 people, we already grown to over 300 people in a number of different locations. But what's for me even more exciting is to take it to the next level and saying, this is fantastic, we're building an aircraft, but how do we make it into our vision to create it for everyone and everywhere? And that's what we are aiming to do. That's what we started with our latest announcement on building the software to create journeys such as JFK to Manhattan for $70 in 6 minutes. We think in a world where we can start building infrastructure, where partners will build infrastructure and create new level of connectivity, such as this type of vertiport that can be anywhere. They're actually not very big and they fit in, and will create not just short new connections, but actually longer connections, and that doesn't exist today. And the way we're thinking about it is to create a customer journey that is going to be different, reimagining almost how you fly. Last night, after 2 hours of delays, I finally managed to get to Berlin, and guess what? We were sitting in the plane for another half an hour until the bus arrives. And this is really what we are thinking of changing, to create a digital experience for the user. You order your plane an hour, a day, a week in advance, but the whole journey is going to be seamless. You're going to know where you're going to have to go at the port, and ultimately also where your plane is in relation to you. So creating an integrated travel experience. So let's take a step back. Of course, we need an aircraft in order to do that. And the aircraft that we're building has some very unique properties. For one, it can fly 300 kilometers. It's pretty far, single battery charge, fully electric, and it can do that at 300 kilometers per hour. It also has 5 seats. So it will be a pilot and 4 passengers, and ultimately, over time, potentially autonomous. But for the start, it is going to be piloted. And last but not least, and very important, it's going to be very, very quiet. What we have done, and where we have very deep tech innovation, is around how the engines of the Lilium Jet are working. A lot of people are saying small engines create a lot of noise, but we turned that around and actually said, look, we're having a duct around our engines. We developed a technology to absorb the noise that those engines make. And with that, already on the prototype, we measured noise levels that would allow us to actually land in Berlin at a few hundred meters distance from the window of a normal office window. And that is going to be crucial in order to make this technology a reality. So how are we thinking about the mobility? How are we thinking about for this to grow? So we are talking about regional mobility. We were actually thinking we're not just limited in connecting certain parts of a city, but we can create a network of connected cities in a way that we haven't known it before. So let's take the example of London. Of course, all very centralized countries that have strong capitals very often, all the routes lead to the main capital. But what about all of these interconnected places? How do you get from the cities that are somewhere on the periphery? How do you connect those? And that is the unique opportunity when you start being able to fly 300 kilometers. You can really rethink how we connect different places. But of course, it works also on short distances. Let's take New York to JFK. I mentioned it earlier. At 63 euros, $70, it's a 6-minute trip at 300 kilometers per hour. So hopefully that is a no-brainer for many people to just jump in. But that's not where we would stop. So we would start with those sensible shorter distances, but then very quickly grow the Lilium network into something that connects an entire region, where you're actually not just doing the airport routes, but you can connect Manhattan to Boston, you can connect Manhattan to Philadelphia, and you can connect Philadelphia to JFK. So all of those cross-connecting opportunities are there. Because different to building traditional infrastructure, you're not going to have to build all of the roads that connect everything with everything else because you fly. So all you have to build is the various different endpoints. And that is fundamentally different to what we've been doing before, how we were thinking about high-speed infrastructure. In the past, it was only possible for the largest of cities to be connected by motorways or by high-speed rail. But now we're changing that game of like any city, a city of 50,000 people can go and build a little port. There's actually one there on the picture, if you can see it, and be connected in 365 degrees, 300 kilometers, at 300 kilometers per hour. So let me give you an example of how this could also work at scale. There's a very famous case study in Singapore to Kuala Lumpur. There was a plan. It's apparently just shelved of $22 billion investment to connect the two cities. And doing that at scale means 1,600 passengers per hour to be throughput through a train network. So we did the calculation and thought about it. So what sort of infrastructure would you need in order to do that with Lilium Jets, right? How big do these ports need to be? And the astonishing thing is, at that size of capacity, you can do it for about 1% of the traditional investment of such an infrastructure investment. And that is fundamentally different. And the interesting thing as well is you don't even need to build that big at first, right? You can also start much smaller and see whether there's even the demand between those two cities and start and grow and expand the paths. These are all options you don't have the way we think traditionally about infrastructure. So when we started, we had to think about how do we make this a commercial success? What are the unit economics of a plane, and what makes commercial flight really successful? And we thought there are 5 key reasons. One, of course, is speed. The faster you can fly, the more passengers, the more trips you can do. The range, the bigger the range, the bigger your area you can cover, the more connectivity you can offer. Payload. The more passengers you can transport on a single jet, of course, the economics get split on each additional passenger. Of course, noise, I mentioned before, very important when you start being close to where people live and work. You want to be as quiet as possible. And last but not least, simplicity. So the whole aircraft was built, and we are currently now in that phase of really thinking more automotive style. How do we make this so it's very, very easy to replicate in large quantities? So how do we create that? But also the original architecture of the aircraft helps us because it is built with simplicity in mind. You've seen it, it only has really 2 functions. One is the moving flaps, and then the other one is the spinning engines. And that creates a very simple aircraft architecture that can do the job. So overall, taking this together and comparing that to ride-hailing mobility, ground ride-hailing mobility, when you think you can fly 6 times faster, you can have probably 3 times the payload because it's so fast, people are willing to share. Last time you flew, you didn't think you were part of the sharing economy, right? But taking that together and comparing that to what is happening on the ground, this aircraft will be 17 times, at the very least, more revenue generating, GMV generating than what you do on the ground. And what's more so on top, because of the economics of the aircraft itself, it's not fundamentally different to what you're seeing in an electric car. Of course, pilots are a bit more expensive. There's a few other bits, but the plane itself is a bit more expensive, but it flies for millions of kilometers. You're looking at not too dissimilar economics than that of a car. So this is going to be contribution margin positive from the first flight. So just fill it, sell it at the price of a taxi that is today the standard between several different routes, and it will be from the day one contribution margin positive. And you can start small. You can start with just 2 different locations that you connect, and you grow it into a much larger network. So with that, thank you very much for your attention. I hope you're going to have a great NOAH. Thank you very much. Okay.